Okay, now we're just going to talk about the different families and groups that the periodic table has and some other characteristics. So we're going to start, very first thing you're going to start off with is hydrogen. In the periodic table that you colored, you notice that your hydrogen is colored a different color. It's colored pink. And why is that? Hydrogen is in a class of its own. It likes behaving in its own little odd way. So we classify it by itself. So it's a gas at room temperature. It has one proton and one electron in its one and only energy level. Okay, it's on the first energy level and it only has one electron and one proton. Okay, it's a non-metal, even though everything else in group 1 is a metal. This is a non-metal. And because it has one electron and it's in the first energy level, for it to be happy, it only needs 2 electrons. So it can gain an electron. If it gains an electron, it's behaving like a non-metal. Non-metals are the ones that gain an electron. But it can also lose an electron. It can also lose an electron, which makes it act like a metal. So it can get a +1 charge if it's acting like a metal and losing an electron, or it can get a -1 charge if it's gaining an electron. And the other thing about hydrogen is that it is extremely reactive. It likes to react. So if you see a hydrogen, it's going to go find some element to react with, whether it's another hydrogen atom to become H2 or some other element so that it can combine. So hydrogen is kind of like its own little beast. Okay, next we have your alkali metals. Alkali metals are everything in group 1 except for hydrogen. So we're looking at things like lithium, sodium, potassium, so on and so forth. Okay, they all have one valence electron. Remember, we labeled that. And they all have a charge of +1. We also labeled that on our periodic table. They are shiny. They have the consistency of clay. And they're easily cut with a knife. They're easily cut with a knife. They can only be found combined with other elements in nature. And why is that? It's because they are super, super reactive. They're actually the most reactive metals on the entire periodic table. They're very, very reactive, so they don't like just being by themselves. They need a partner. And when you put them near water, they react violently. So all alkali metals behave this way. The extent to which they react violently with water depends on where they're located on the periodic table. And I'm going to show you a video right now.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium.
Notice when he cut the lithium with a knife, so it's a very soft metal, that this went from really shiny to somewhat dull and tarnished, kind of black again. That's a chemical reaction. Remember, we talked about about these alkali metals being very reactive. This is an indication of that. So let me show that again. He's cutting it with a knife. This is lithium.
Rubidium, cesium, and francium. They're all
It's shiny.
metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears.
There's a chemical reaction happening on the surface. Now this is going to be sodium. That's the next element down this periodic table for the alkali metals. It's right below lithium. Sodium is usually kept in oil so it doesn't react with air. So we'll remove it from the oil to do the same thing that they just did to lithium.
Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium.
This is potassium right below it.
So quick that it's hard to see the metallic luster.
Right away, it becomes a little dull.
The elements seem to react more quickly with air.
Remember, these alkali metals are very, very reactive. But as you go down the periodic table, they become even more reactive. They're reacting in a similar fashion, but they're reacting much quicker as you go down the periodic table. So you go down the periodic table, you're adding energy levels. Okay? So your valence electrons are further away from your nucleus. The further away you are from your nucleus, in this case, things are reacting in a way that's a little more extreme. Okay, now they're going to show the reaction with water. Remember we talked about how these are violently reactive with water, so we're going to start with lithium and work our way down. And you'll see that the reaction is getting a little more extreme with each energy level you're adding. Same number of valence electrons, new energy levels. Starting with lithium.
Another reaction of the alkaline metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkaline metals react with water in the same way. Let's see an equation for the reaction.
So all of these alkaline metals will react with water to produce hydrogen. That's what you're seeing. And the heat that's being produced is due to the production of hydrogen gas. So in this case, it's sodium, Na, plus water, gives you hydrogen and then sodium hydroxide. When you do it with lithium, it would be lithium plus water to give you hydrogen plus lithium oxide. When you do it with potassium, it would be potassium plus water to give you hydrogen plus potassium hydroxide. When you do it with rubidium, it'd be rubidium plus water to give you hydrogen plus rubidium oxide. It is the same reaction, same product, and it's predictable because they all have the same number of valence electrons.
Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium.
Potassium, next one down in the periodic table. Oh, so this is so fast and it produces so much heat, so it catches fire. That was potassium. Now let's go to rubidium. Look at that, rubidium.
This time, we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group.
More violent of a reaction. Now we're going to try cesium.
Our fifth alkaline metal.
Okay, that becomes a lot more reactive. Okay, now we move on to the second column. Those are called the alkaline earth metals. This is group 2. Everything in group 2 has 2 valence electrons, and they're going to form charges of 2+. If they're going to become electrically charged, it's going to lose 2 electrons to form a 2+ charge, because it's easier to lose 2 electrons than to gain 6 in order to get that octet, to get 8. So everything here is going to be a +2. They're very reactive as well. Just like the alkali metals, the alkaline earth metals are very reactive, but not as reactive as those alkali metals. And just like the alkali metals, your alkaline earth metals are never found uncombined in nature. They're always reacting and combining with other things. Okay, next we have our transition metals. That is that middle part, right in the middle of the periodic table, kind of flat part where the d orbitals sit. They make up the largest group of the periodic table. They're good conductors of heat and electricity because they're metals, right? They're mostly solids at room temperature, except for mercury. Mercury, which is right around here, is a liquid at room temperature. And these guys tend to have 1 to 2 valence electrons, but we would have to tell you how many valence electrons there are. You wouldn't know them just offhand. Okay, and this is what mercury looks like. It is a liquid at room temperature. It's a metal, but it's a liquid metal. It's melted. Okay, so because they're metals, they have luster, they're shiny, they're malleable because they're metals, they're ductile, and they're brightly colored. This is where you get your color for your paints, is in your transition elements. And then they have 1 to 2 valence electrons, which they lose when they form bonds. They like to become cations, become positively charged. Okay, so these are some transition metals, and you can see that they have some color to them. Okay, next we have the boron family. The boron family. That is group number 13. They have 3 valence electrons. Everything in that group has 3 valence electrons. And then this family includes 1 metalloid, because boron is a metalloid, and then the rest of them are metals. It also has the most abundant metal in the Earth's crust, aluminum. The most abundant element is oxygen, but the most abundant metal is aluminum. Okay? And they share physical properties of transition metals, but not chemical properties. They look like transition metals. They have, luster and things like that, but they behave differently because they have a different number of chemical properties. We're going to watch a video now on one of the elements in the boron family. That's kind of a neat element. So please check Schoology for videos on gallium. We'll watch one in class today. Okay, so next we have the carbon group. That is group number 14. The carbon group. It's got carbon at the very top. These have 4 valence electrons. They include a nonmetal carbon, some metalloids, and some metals. Actually, just 2 metals, 2 metalloids, and one nonmetal. An example of the carbon family is silicon. That's used in computer chips, and that's the second most abundant element in the Earth's crust. Most abundant was oxygen. Second most abundant element is silicon, and the third most abundant, but the most abundant metal, is aluminum. Okay, carbon family. These guys tend to make what's called covalent bonds. We'll learn about that later. Okay, next we have in group 15 we have the nitrogen family. Nitrogen makes up 78% of our atmosphere. This family includes a nonmetal, a metalloid, and metals. They have 5 valence electrons. They tend to want to share electrons when they bond. That's called a covalent bond. And they tend to want to gain 3 electrons, so that they can, if they gain 3 electrons, they will then have 8 electrons total. So they gain 3 electrons, they tend to want to have a -3 bond. Next family, group 16, is the oxygen family. It's got oxygen on the top. These guys have 6 valence electrons, so if they're going to get a charge, they're going to get a charge of -2, because they're going to gain 2 electrons. Most elements in this family share electrons when they form compounds. Again, these are covalent bonds. And it is the most abundant element in the Earth's crust, and it's extremely active and combines almost with all elements. Oxygen loves to combine, loves doing reactions. Very friendly element. Okay, next we have our halogens, group 17. They have 7 valence electrons, so they are 1 electron away from hitting that perfect octet. So they're going to try to get that 1 electron by all means. So they're going to form a -1 charge many times. They're very, very reactive. They're the most reactive of the nonmetals. Our alkali metals are the most reactive metals. The halogens are the most reactive nonmetals. And they love to react with alkali metals because alkali metals want to get rid of their electrons, and halogen wants electrons. So it's a nice little marriage. This is iodine. It is a solid. Right above it is bromine. Bromine is a liquid, and then the rest of them are gases. Okay, then we have our noble gases. They don't react with anybody. That's the very last row. Group 18, they have 8 valence electrons, with the exception of helium, which has 2 valence electrons. They are all gases, colorless gases. They're extremely unreactive. The word for unreactive in chemistry is inert. Their outermost energy level is full. It has 8 electrons, 2 in the S and 6 in the P. So we're completely full. There's no room for any other element to come in and react. Therefore, they are unreactive. And they're found in small amounts in the Earth's atmosphere. Okay, at the very bottom, we have our rare earth elements. That's the 2 rows at the bottom. They're composed of the lanthanide, which is the top row series, and the actinide. Why is this called the lanthanide series? Because it starts from here, it drops here to a lanthanide. First element is the lanthanide. Okay, the lanthanide elements, the one in the top row, are used in lamps, lasers, magnets. They're used in motion pictures, projectors, things like that. The actinides down at the bottom are the ones that are radioactive, and they're used in atomic bombs. They're also used in cancer therapy. They're the ones that will produce that gamma radiation we talked about. Sometimes these are called the intertransition elements as well. Rare earth metals, lanthanides, actinides. Okay. You should have colored your periodic table to show all of these things, and next I'll show you what that periodic table should look like. Okay, this is what your periodic table should look like, colored. Okay. If you notice, most everything is yellow. Those are your metals. Over here in this orange spot, those are your nonmetals. These are your metalloids. You were told to put a little dot in all the alkali metals. So we've got one little dot in alkali metals, and I made a little key. They told you to draw a line across your alkaline earth metals. That's those. You were supposed to draw lines like this through your transition metals. That goes all the way up to here. Okay. Your noble gases were supposed to have checker marks, and your halogens were supposed to have little dots in them. This is your lanthanide series. This is your actinide series. And I've labeled a couple of things that are kind of interesting about them. Down here, this is where you're radioactive. These are radioactive. These parts right here only exist in a lab. They've been made by humans. Up here, they're slightly reactive. Here, I put their inert, unreactive. Your halogens are very reactive, and I put for your alkali metals at the very top, extremely reactive. Okay. Your periodic table should be labeled because it will help you on your tests and just doing your assignments. Thanks.